Hello. It's been a long time since I've made an antenna. And yeah, I'm going to go close this door over here first before anything because it is a little too bright. Perfect. I'm sure that'll be better. So, yeah, no, it's a long time since I came up with an antenna. In my quest for building the most lightweight, bare minimum sort of systems that utilize other things in a quick pinch. For instance, this particular antenna here that I have in front of me is a 3-element 2-meter Yagi antenna constructed with 10 poles. So the intent for this antenna was to build something that's good for backpacking. My wife and I are going to be aiming to do some backpacking by the end of the year, and I wanted to bring something that would give me a little more punch, a little more bang for the buck for the radios that I'd be bringing down with me. I'd likely be bringing down some kind of Baofeng UV5R or something like that. I don't know if I'd want to bring my Yaesu down. Plus, I have spares for everything for the Baofeng since they're so cheap and easy to get parts for. So um, that's my intent on using this. I don't intend on going any higher than 5 watts on this thing. But yeah, the intent was to build something for backpacking, and that would utilize something for a boom arm that I would already be carrying with me for backpacking, and that turned out to be tent poles. Now, the ones I used here in this design are they're like the fiberglass ones with these little metal crimps that you use to seat everything together. And there are some poles that are metal as well. I haven't tried it with metal poles. This is the first prototype that I have, so I have really no idea how a metal one would react. But all of the elements here are isolated from the boom with these little pieces that I designed and printed. And then it goes to a male SMA connector. This is just another one I was using when I was testing it out with the SWR meter. But yeah, it goes with a male connector there at SMA connector. And then a little short length of wire, a couple of crimp connectors at the end to bolt it to the antenna. And that's it. So I actually, the design has changed since I put this together. This middle piece will be changing a little bit to accommodate some new pieces that I got for different connections. So I presume that all the lengths of these elements will change a little bit. But let's disassemble it so I can put it all back together in its package. You can kind of see what it all looks like when it's disassembled. All right, so this is it, all put together. Everything packs in here. Now, this is actually more than you would need because I'm including the tent poles that I used for this prototype in this pack. But technically, all you would need is the elements, the cable, and then the connectors to connect the little adapters that go onto the tent pole that you connect the elements to. So that's really it. But before I do anything, before I open this up and we kind of assemble it, I wanted to get a weight reading. I don't mind this dirty scale. Well, that's going to be, well, we'll get a close in a second, or a close up in a second, but we're going to turn it on. We'll set it to ounces because I think that's and then we'll put this cup on there as a stand. We'll tare it. Okay, so now it reads 0 ounces. We're going to throw this on top. Well, let's wrap up that cord so that doesn't do anything. And we'll put it on top. And so it's 11.88 ounces with everything that's in here right now. So let's pull it out. I'm just turning this thing off. All right, let's pull it out of the package and see what it looks like here. All right, here's the top. So here's everything that I've packed inside. All right. Oops. There we go. All right, so you've got 6 telescoping antennas. I said that really funny. 6 telescoping antennas. Telescoping. Whatever. Little fabric measuring tape, and that's important for later. We've got the cable to connect everything up. And like I said, I'm including these tent poles in this particular build because first of all, I had them. They were old from another tent. And secondly, I don't really have the measurements that I have set up on here between these adapters, but I'll go through these adapters to show you what it does. But again, take these tent poles out of the equation here, add these 3 connectors to this pile, and that's all you have to bring with you if you're backpacking or camping. Well, it depends on what you're doing, right? Because you don't want to have to keep taking your tent down to use it as a boom. I would suppose if you're camping, maybe this would work well. If you're backpacking, maybe you use your tent poles because then you only need this. So let's see what that weighs. In fact, zero that out, and I'm just going to add these to the pile on top, not including. Well, let's see. Hold on. I have a couple of these spare pieces over here. So we can add those to the mix. Here, yeah, I've got some of these adapters. That's cool. Okay, so I'll throw some of the adapters on. 5.6 ounces is what it's showing. 5.60 ounces. So that's nice. This is all you would need to bring with you if you were on a backpacking trip. Well, 2 of these, not 1, but yeah, it's not going to add much to the weight. So yeah, these adapters here, basically they clamp onto the pole, and I'll be designing them. Wow, it's really bright over here, but I'll be designing them to have a little padding on the inside, print a little padding with some what is it, TPU, I think it's called. Yeah, and these go in with a couple of thumb screws that I make with some press-on fittings and socket heads. And yeah, and then your driven elements, can't speak this morning, driven elements go into this threaded coupler that I've press fit into the inside of this. And this one happens to be larger. This is for the driven elements. So the reason this is done like this, so you'll notice that one side has a hole, the other side has a hole, but it's offset on the other side. There's a 15 millimeter offset between here. And I based this whole design off of, oh God, I can't remember what site it was. It was an Instructables that I saw. If you were to go on Google's and Google's, gosh, I cannot talk today. If you were to go on Google and look up 2 meter, 3 element offset driven elements antenna, you'll find an Instructables written by a guy who made one of, not made one of these, but he made an antenna, and I based my design off of this. And basically what it does is it utilizes a gap in between your 2 driven elements to create the proper feed point impedance on this. So that's why this one looks a little bit bigger, because this is specifically for driven elements. Now I've already changed this design. These holes go all the way through. I've gotten a larger coupler, so I'll be able to attach the antenna to one side and then the wire to the other. So right now I'm basically just pinching it in between the coupler and the antenna, but it works. We'll do some SWR readings at the end of this video, and I'll show you it's nearly perfect. I was getting 1.1, sometimes 1.0, but 1.1 to 1.4 across the band, 1.4 on the lower frequencies, and then it got better on the higher frequencies. But I was tuning it to 14652 for the national simplex calling frequency. But yeah, so those are the adapters. The adapters get attached to your tent pole, and technically you only need 1, 2, 3, 4. You only need 4 lengths of tent poles. I guess really it depends on how long your tent poles are going to be. So maybe you need 5. I have an extra one in this because after I built the antenna based on the other design online, I found that I was getting horrible readings in 2.3, 2.4. So what I ended up doing was changing the position of these here. So let me put this out, I tied it nice and tight, so it basically self-assembles. But I changed the position of these adapters on the tent pole. Interesting. That one looks like it was coming. Oh, it's cracked. That's why. Yeah, I forgot I cracked it last night. But anyway, yeah. So I changed the spacing between these based on this cool little thing. Where did I put it? It's in this room somewhere. I know it's in this room somewhere. Oh, it's right here. Based on this cool little dual band cross beam Yagi antenna thing that I got for satellite work, which is kind of cool. The reason I got it is because it's dual band, right? So I can decide to bring just the 2 meter stuff with me, or the 440 stuff with me, or bring both. But the only thing with this is it's heavy. It's a lot heavier than this thing. But what I did is I based the element spacing from this and applied it to this boom. So the element spacing between here matches this one. I forgot what brand this is. And then I matched the element lengths to this antenna and then tuned from there and got something nearly perfect for 14652, which was awesome, if you ask me. So essentially, the setup goes like this. Now you can do it one of two ways. I haven't really figured out which the best way to do it. I ended up once I got those measurements, I ended up getting this fabric tape and putting markings on here that say reflector, driven element, reflector, so I know exactly how long to make the elements. These are half lengths, so they do one side at a time, right? If you want to know the full length of the element, then you would just double the number that I've lined this up to. So like here in this case for the reflector, it's 56, 1, 2, 3. So 563 or 56.3 millimeter or centimeters, 563 millimeters is the half. So you just double that and you get the full length. Oh, I'm sorry. I had that upside down. Reflector is 54 and a half. So 545 millimeters. So yeah, that's an example. So what I end up doing is, or what I've been doing so far, is taking my antenna, going just below the thread, just going past the thread, sorry. Just going past the thread, and then pulling out the antenna nearly all the way. So I only get the thicker portions. I mean, it does matter a little bit, but I think it's going to be pretty forgiving, to be honest. And then I get it to be the length of, so we'll do the director first. A little bit more. And then we can double check these and fine tune these afterwards. So I've got this one, and now let's make the other one. And here I can just match the lengths of the two. Just do one of those numbers. So they're about even. There we go. So there's my directors. Now we're going to do let's do the reflector next. So bring it out, push the thin parts back in. All right, we'll go almost up. Reflector needs to go down more. So we'll just push it down, push it down, push it down. Cool. That's about there. Now, these aren't, right now I'm not doing exact measurements. I'll do that after these get installed in the thing. Oh, I got close to that, didn't I? I was like 2 millimeters off. Cool. All right, so there's my reflector, and then my driven elements. Same thing. The piece I designed is symmetrical, so it's you can use the same lengths for both of these. All right, so about halfway up, we're going to do, that's director, driven elements down here. Okay. It'd be nice to have some colored tape for this. All right, so I'm going to hold this here. Push this down. Yeah, got to pull it out a little bit more. This driven element is a little bit more finicky, so I'd like to try and get it as close as possible. Well, it has been. I haven't. I actually haven't used this antenna. I've only proofed it through the SWR meter, honestly. So, but we're going on a trip in in May, so I'll get a chance to try it out then. All right, so now these are attached. Now we can, or these are spaced out to they're extended. We're going to leave the driven elements unscrewed just slightly because we still need to attach the cable. Okay. These go in the holes and then drill in. Okay. Here. And what's nice is you can, if these get turned a little bit, you can just rotate the tent poles. It's very forgiving. Yeah, it was funny. I knew I had an issue with my driven element earlier this morning because when I sounds like UPS is here with my McMaster parts. Awesome. But yeah, when I turned the director 90 degrees to the rest of the antenna, my SWR dropped like 4 points. It was ridiculous. So yeah, so that's how easy it is to build. So now let's do a double check on our measurements. Let's do the director first. We'll go from the center. Thank you. Okay, so the director's good. Sorry, I was yelling at the UPS guy. Well, I mean, I wasn't yelling at him, but it looks like we can go out a little bit more. This is where the fine tuning comes. Okay. And I think what I'm going to end up doing is adding a little hash mark in the middle for an alignment window. So now we're going to do the driven elements from the halfway point, or what I think the halfway point is. Hey, look, we're pretty dead on that one. Let's do the reflector on this side since I'm on this side of the table. Reflector needs to come out just a little bit, just a hair. Just a hair. Maybe 3 hairs. Perfect. All right. Since I have the reflector in my hand right now, we'll put the reflector next over here. That looks pretty dead nuts on. And we'll do the driven element up here. Okay, so this one needs to be poked in a little bit. Perfect. That looks good to me. So yeah, so that is the entire setup. And now you attach your cable. So we're going to flip this thing upside down. And you can see how long this boom arm is on the back side of this. That was unintentional. The original design required 5 tent poles, and I really only need 4. So you see here, I really only need those 4. But we'll deal with that in a second, because I came up with a way to deal with that. But, you know, it might not hurt to have that extra length on the boom arm. Okay, so now I put my driven element in front. So we're going to put that bad boy here. And it just clamps in between the antenna and the nut. Hopefully you're seeing this in the video. It's hard to do it and it's like still stay viewable in the camera. There we go. Okay. All right. Now we can take this bad boy back. Use this to tie up our remaining cable and tent pole. There we go. Now we have it. It feels a lot more flimsy than it really is. It looks a lot more flimsy than it really is. You can't even see it. There it is. But yeah. So now we'll hook that up to the SWR meter, and you can see the readings. All right, well, I've got the antenna outside, and we're going to try and do this all behind the camera. All right, we're going to plug it into my MFJ SWR meter. So I've added an adapter from the SMA. So it'll work with it. So I'm a little lower to the ground than I was when I first tuned this thing, so I don't know how that'll affect it, but we can always play around with it. Let's turn the power on. Aha! Right, I unplugged the power to this thing, so I gotta go plug it in. Okay, now we have power back to it again. Gotta bring the antenna back up. It's still the one that's connected to this guy. Let's turn it vertically. And let's turn this bad boy on, get the cable out of the way. Some of my elements are not lined up properly, but that's okay. I just turn them to fix them. And there we go. All right. Okay, so actually, well, that is quite interesting because now I have 40 ohms when before I had 50 ohms. I'm still at 1.2, and if I go down the band, 1.1, so it looks like it's best on the lower ends of the band. But it's pretty darn good throughout the entire band. It could probably be updated just a little bit. I don't know why. Let me let's do 145, 146, 52. 146, that's pretty close. Let me step up. Interesting. So yeah, I don't know why the resistance dropped. I'm just touching the antenna and bringing the, expanding the director. I'll bring it back down. But anyway, yeah, I'd say it works pretty decently. We'll have to give it a radio try at some point. Yeah, so that's about it. I'm not going to do a radio test on it now just because I don't really feel like pulling out all the radio gear and stuff like that, even though it is easy enough to do. But yeah, I don't know. Maybe not feeling up to doing radio things right now. But here I am, building an antenna for radio. Go figure. But yeah, so hopefully this will be something that I can use successfully when we go on a backpacking trip. Or at our next camping trip. I know where we're going to be going. We'll be at a good elevation, but we'll kind of be in a valley, sort of. It's like a high valley. Oh, let's take this thing off because we don't need that. Yeah, it's like a high valley. So I don't know. I could probably still get out to some repeaters and all that jazz from where we're going to be, but what fun is it if you can't build an antenna and try bringing it with you? Yeah, All right, so there we go. So yeah, just a reminder, this could be all you need. Two of these little guys. One of the driven element things, your cable, and this. And then of course, whatever radio you're bringing, you just got to make sure you have an adapter to go to this male SMA connector, which again is not the one that Baofeng has. Baofeng has the male SMA connector in their radio, so I would need a female coupler for this particular one. Yaesu, on the other hand, does have the female. So who knows? My intent is to bring a Baofeng when I go on camping trips because I don't want to destroy my Yaesus. But at the same time, Yaesu just might be better. It might be. That's a stupid thing to say. Of course it's better than Baofeng. Also, this little measuring tape. Now, something that I thought about, I could, replace this measuring tape here with just a string, like a paracord type material, and dye certain ends of it. So like, maybe dye one end of it completely black, and that's the starting end, right? And then I have, a marking for the director, a marking for the driven elements, and a marking for the reflector, just kind of like I have done here already. So that's a thought, because that would take a lot less room, and then you just have a piece of paracord, which is something you already use as well. So when you're camping or backpacking. So yeah, just thought I'd share that. That all goes in here. Really just to document it, for Pete's sake.